So, um, today's lecture is on entity linking, and like last class, so today we'll have some bit of MCQs, and then I'll show you a small demonstration of how this works. All right. So let's see this then. All right. So, like the first question is, which of the following phenomena can pose a challenge to the task of entity linking? So, the first is the variations in textual representation of the same entity. Yeah, like the entity can be mentioned in different ways, abbreviated names, multiple entities with the same name, or missing attributes of entities in the database. So, can you tell me which ones will apply, like if you can guess? So, which of these can cause a problem in understanding the different mentions of the same entity? What do you think? Anyone? Okay, then let's see. So, these are the correct options. So, you have to understand why. So, because if the same entity is represented in different ways, say somewhere the for a given person, say somewhere the middle name is mentioned and somewhere it is not. So, both those two textual representations actually refer to the same entity. So, when there is a variation, then that can cause problem in entity linking. Obviously, when you do abbreviation of a name, then the same thing happens. The textual representation changes actually. So then again, that's a challenge. And finally, if you have the same entity name but they refer to different people or different things, so then that is another kind of challenge where the multiple entities have the same textual representation. So all these situations can be challenging when you are dealing with entity linking. Okay, so the next question is, in the task of wikification, what is the order in which following steps are performed? Mention detection, entity disambiguation, and link generation. So these are these three tasks, as you know. So what is the order in which they have to be performed so that we can disambiguate between the entities? Anyone? All right. Uh, so the answer is this. Now you have to understand why. So the first step is mention detection. So as you know, you have to first find out all the mentions of named entities in the document. So that has to be done first, and then you have to generate links between them and the different Wikipedia articles. And then finally, after generating the links, you can do disambiguation. Okay, so that is the process. All right, so the third question is, can one build an accurate mention detection and disambiguation system using key phraseness and commonness? So is this possible? All right. So these are the two correct options. Basically, the thing is, if you know the formula for commonness, it will, like, for a given mention, it is based on the denominator is the sum of all the links, and the numerator is the number of links for that given concept. So that is why what happens is the concept which are frequent, they will be dominated in commonness. And also, commonness does not take the context into consideration because it just sees which one has a link. Okay, so let's look at a few problems with numbers, then we'll understand these things. So there's a text which is S Tokyo, and it occurs in 500 different Wikipedia articles. Now these are the different concepts it is linked to. So C1 is 316, C2 is 110, C3 is 10, C4 is 7, and there are 57 instances which have no link. Okay, so we have to calculate the key phraseness of Tokyo. So okay, tell me whether option 4 is correct or not. Like, do we have enough information to calculate key phraseness? I guess I'll show the answer. So this is the answer, and this comes like this. So basically, the information given here is sufficient. So we have to find out the key phraseness of Tokyo by adding up all the concepts which are linked, and we have to divide it by the total number of times we see Tokyo. So that is how this works out to this value 0.886. So we add up all these instances C1, C2, C3, C4, not this one, no link, that is excluded, and we divide it by 500. Okay. So now the next question is, what is the commonness of S and C4? Like the commonness between the string S, which is Tokyo, and the concept C4. So this is the values. So what is the commonness? Alright, so this is the answer, and that is simply given in this way. So as I said, commonness depends on the number of links to that given concept divided by all links to, like, all concepts. So that is why here C4 had 7, and like the sum of C1 to C4 is this value 443. So that is why this comes to this value. Okay, so information extraction can directly help in which of the following downstream tasks? So as you can see, there are 4 downstream tasks mentioned. Uh, in which can information extraction help directly? Well, these are the correct answers. So, uh, like, entity linking is actually used for information extraction, and after we do that, we can create the knowledge base, and we can also answer questions based on the knowledge base. So that is why these are the 2 correct answers. Finally, like, this is the last MCQ. After this, I'll give you a short demo of how to do entity linking. So what are the drawbacks of using hand-built regex patterns for relation extraction? So low precision, not possible to extend to new patterns automatically, costly to obtain a large set of such patterns, and cannot utilize easily available text from large corpus. So yeah, like what are the problems when we do some handcrafted thing? That is the thing we have to understand over here. So obviously it's not low precision, because when you do anything by hand then it is more precise. So that is why anything, like all the patterns which are crafted by hand will be more precise, but then they will be fixed. You can't extend them automatically because they were created by a manual annotation process. And obviously because it involves manual handcrafted annotation, so it is costly to obtain this large set of such patterns. You can only do a limited number due to cost of time, effort, everything. And also, like, when this manual process is done, then the human being cannot take into account the entire huge corpus for building those rules. Those are built on some logic or known ideas. So that is why text of a large corpus cannot be utilized for this thing. So these are the answers. Okay. So as there are not too many people here, so I'll just show a little bit of how we can do this in Python. So just give me a second. Yeah, so I'll show this. So okay, can you see the screen? So this is a sub module for Spacey. uh, okay, not clear. Is it clear now? Okay. So as you can see, this is a Spacey entity linker. So if you don't know already, so Spacey is like a Python package which is used for doing some NLP tasks. So it has some trained models and all that. You can do things like post tagging, named entity recognition, all these things you can do using Spacey. And so this particular GitHub repo, like, that is an add-on on top of that. Like, they have explained how you can do it, so there is a short explanation to it. Although, like, in modern versions, Spacey also gives some kind of entity linker. So we will have a look at this one for now. All right. So yeah, let's see how to do it. So first of all, before we go there, we have to do these two things. So firstly, you have to install Spacey, which you can do in this way. So just give me 1 minute. Yeah. All right. So okay, let I'll show you from here only under usage. Yeah. So this is the main screen. So if you go to spacey.io, then you go to usage. They will show you how to install. So you have to follow these steps. So for example, you select the system. Can you see like you have operating system, platform, package manager, then hardware and all this. So you can select all these things and they will give you the commands you have to execute. So if you execute them, you'll be able to install spacing. Okay. Now after having done that, you have to go to this GitHub repo. So I am giving it over here. I'll also mention it in the last page of the PDF. Okay. Now we have to run these two lines first. So first you run this. That will install this package Spacey Entity Linker. This will get installed. And then we have to download the knowledge base so that we can do entity linking. So this is based on Wikipedia. So you have to run this. So both are in the home page of these things. So you can directly look at them while running. Now let's look at the examples of the code. So they have given some examples over here. All right. So we will also try to replicate that and see like how it works in a different context. So firstly you have to do these three steps: import spacey, then you have to load the language model. So what is this language model? So if you see here, you have downloaded something over here, Ncore WebSM, and over here they are suggesting Ncore WebMD. So this is larger, that is small. SM means small. This is a smaller model, and this is a medium. Like MD is for medium, so this is a slightly larger one. So you can download whichever one you want. The one you will download over here, that one you have to use over here when you do spacey.load. So I recommend that whatever you do, you can do using the small. No need for the medium. So we can do SM. Okay. Then it is this line. So we want to do entity linking. So that has to be added to this spacey module, and it comes at the end. Okay. So this is kind of default settings. So we'll just run them. Some I have like this is in IPython, so I have it installed. You can write simple Python scripts and run them also. Like everything works. So we do okay. So you can see this, right? Is it visible? So let's see. We did import spacey. Then we do this NLP equal to encode WebSM. I'm doing with the small one, and then we do nlp.addPipe, and it will show that a spacey entity linker has been created. Now if you see, they have given an example. I watched the Pirates of the Caribbean just 1 second, last Sylvester. um, Can you see Sylvester? Now you can see, right? I watched the Pirates of the Caribbean last Sylvester. So then what they do, when you call it like this NLP, then it processes the spacey model processes it, and then they are printing all linked entities, like all entities in this string which can be linked to Wikipedia. So they did do that, and they print them out. So as you can see, the first is Pirates of the Caribbean, which is like series of fantasy adventure films, and then last Sylvester. So Sylvester over here is actually the day celebrated on 31st December. So like that is something like some holy day. So these are two entities which have been detected. Now we can do that here also. Let's do it in like for our Indian context. So we can do doc equal to NLP. I will watch Brahmastra this Diwali. So we can give something like this, and it processes that. Now we will see how it works. So and then so as you can see, they have detected that the first one is Brahmastra 2020 film by Ayan Mukherjee, and the second is Deepavali, which is the festival of lights. So this is a pretty standard model. You can use it in any kind of data. More or less, it has good accuracy. So even in our context, it can detect things. So let's have some more look at some more examples. So now these are the entities. Fine. In this part, they found out what the entities are. Now we might have to understand that what are the categories that these entities belong to. So when we do something like print super entities, then like the classes will be printed. For example, like they have given Elon Musk was born in South Africa. Bill Gates and Steve Jobs come from the United States. So when they are doing super entities, it's showing like Elon Musk, Bill Gates, Steve Jobs, these are like under human. South Africa and US, those are countries. South Africa and US are also sovereign state. Then US federal state, US constitutional republic, US democratic republic, and so on. Okay. So let's see what happens when we do this in our context. So let's try something else, something like, so Narendra Modi was born in Gujarat, India, and Donald Trump and Joe Biden come from the United States. So it's like a similar format as they have used. We did this, and then when we do print super entities, so as you can see, all three are human. India and US are countries. They are sovereign states as well. Then Gujarat has been additionally identified as a state of India. India is also a republic, dominion of the British Empire. Then Donald Trump also falls in this category of billionaires. And then we have these things which were there for US as in that example as well. Okay. So like you can find out the super categories for any named entity, like what are the categories they belong to, and then you can extend that any way you want. Okay. And finally, we'll take one more example. So they have listed over here all the things that you can get with an entity type object. Okay. So all these things you can use for like you can use these for printing out the different details of the entity. And then as you can see, there are these two functions, get super entities and get sub entities. So all entities in a knowledge base, they are arranged in a hierarchy. So like for example, we saw over here that Modi, Trump, Biden, they all fall under the category of human. Similarly, uh, we have these things, and then you can find out the parent in the hierarchy or the children in the hierarchy. So they've given an example like, say, fruit is the parent and apple and banana, they are like the children. So each of them are entities, like that. So they have done another example over here. So they are saying, I follow the New England Patriots. So that is a football, like American football team. Now, not the football we know. So that's an American football team, and they print this out. So you can see New England Patriots National Football League franchise in Massachusetts and so on. Then they are getting the super entities. So we take the first one out because sometimes there might be multiple super entities. So the first one is taken and printed out. So that is being shown like it's an like a American football team, like organization in which a group of players are organized to play football. Okay, to compete as a team to play football, and then taking the parent, they find out the children. So the parent over here is an American football team. So just like New England Patriots are a team, there are many more teams. So when we do this, then a list of all different teams are printed. Okay. So if we do in our context, we'll see the same thing. So let's do I follow my Indians. So which is like an IPL team. Okay. So what do we get when we do this? Let's print it out. Let's just use this itself. So it's an IPL franchise. You can see that it detects it as an IPL team. Then when I'm running this one, finding out the parent. So what is the parent? The parent is a cricket team. So like the parent category is just cricket team. Like over here we had uh, over here we had American football team. So here it's just cricket team. All right. And then when we do the other part, you will see the names of different cricket teams. So like these are different cricket teams, right? So we see that. So we have IPL teams, we have national teams, under 19, like all list of teams which are there in Wikipedia categories. That has been like 32 of them have been printed out. Okay, all right. So that's more or less all. I'll add the links I added in the chat. I'll add it to the PDF as well. So, okay. All right. So not anything more for today. We don't have much material. So that's it for today. If you have any doubts or any other questions, you can ask. All right. So thanks then. Uh, and we'll end it today here itself. Yeah, actually, I have completed today's session. It was not a long one. There was very little things to cover. So,
Okay, I'll join the next session.
yeah, if you have any general doubts, you can ask that.
No, no, no. I'll join. I'll join the next session. It's
All right.
okay. Okay, thank you.